Okay, so we were discussing in our last class, we were discussing the general methods of preparation, and we had done a few. For example, we did from oxidation of aldehydes and ketones, we did the hydrolysis of cyanides. So these are a few of reactions, and then we also did the hydrolysis of trihalogen derivatives. So these were the few reactions which we had already discussed. Let's go on to certain other methods of preparation over here. The next one, the fourth method of preparation, which we are going to continue from our last class, that is from Grignard reagents. From Grignard reagent and carbon dioxide. Okay, now in this case, when we are talking of carbon dioxide that is going to have this kind of a structure. Okay, now over here again, mechanism of the reaction will be same as we have discussed in the aldehydes. The R that will go and attack at the carbon and NGX that is going to attack at the oxygen, such that the reaction that is going to take place in presence of dry ether because of very high reactivity of the Grignard reagent. So what are we going to get over here? We will get CrONGX. Okay? And then hydrolysis of this H2O. This is going to give us C double bond O R OH, which is going to be the respective monocarboxylic acid which we are getting over here, and plus MgOH. Now in this case, please remember that the number of carbon atoms which are going to be present in the carboxylic acid form, that will depend upon the alkyl group which is attached at the Grignard reagent. The reason, the alkyl group which is attached over here, the reason behind that is that carbon dioxide that can only have one carbon atom. So the number of carbon atoms present in the carboxylic acid form will depend upon the number of carbon atoms which are present in the Grignard reagent. So let's take an example over here. We are taking over here CH3 NGBr plus carbon dioxide in presence of dry ether. So what are we going to get over here? CH3 will attack at this position and MgBr that is going to attack at this position, such that we have over here again C double bond O MgBr. इसको थोड़ा सा और आगे कर लेना. So we are going to get over here O MgBr and CH3. This on hydrolysis that is going to give us O double bond C CH3 OH acetic acid plus MgOH and X. Okay? Now if we are taking a tertiary Grignard reagent, tertiary Grignard reagent means that we are taking CH3 whole thrice C NgCl. Then what is going to be the product over here? Double bond O. This group from here that is going to attack at this carbon atom, and NgCl that will attack at the oxygen. Again the reaction in presence of dry ether, and this is going to give us CH3 whole thrice C, and we have over here C OH double bond O plus NGBr and OH, right? So here you can write down that you are reacting it with dry ether over here in the first reaction, and the second we are doing the hydrolysis of the product form such as to give over here 2,2-dimethyl propanoic acid. This is going to be the acid which is formed over here, right? 2,2-dimethyl propanoic acid. Okay, then after that we have the next one. If we are taking a cyclic compound over here, in case of cyclic compound, what are we going to get? Cyclic compound, for example, we are taking a Grignard reagent, cyclohexyl magnesium chloride, and we are reacting this with CO2. Now it is going to be the cyclic the cycle which is going to attack at the carbon atom. So what will we have? We will have C double bond O, ONGCl, and the cyclohexyl group that will attack at the carbon atom. And after that, when we do the hydrolysis of this, in presence of H positive, this is going to give us C double bond O and OH. Okay, so this is going to be the product which we are getting, cyclohexyl carboxylic acid. This is how you are going to name it. Cyclohexyl carboxylic acid, and plus we will get NGCl and OH. So this is how we can prepare the carboxylic acids from the Grignard reagent. Now over here you will see that the acid form that is going to have one carbon atom extra than what is present in the Grignard reagent, because if you are looking at RMgX over here the product form that is going to have one carbon atom more than that what was present in the alkyl group. This carbon atom that comes from carbon dioxide with which the Grignard reagent that is going to react. Okay? Then we go on to the fifth method of preparation, that is hydrolysis of esters. Okay, so we have over here the fifth method of preparation, which is hydrolysis of esters. Hydrolysis of esters we are going to do the acid hydrolysis over here. So it is going to give us a mixture of alcohols and acids. For example, if we are taking a general reaction, this is RCOOR, which is going to be the ester, plus water in presence of H2SO4, acid hydrolysis which we are doing. Now over here the cleavage of the bond that is going to take place from here, because we have H, right? So ROH, OH comes from water, and H over here comes from from water. So we get RCOOH plus ROH. This reaction is the opposite reaction of esterification reaction which we have already done. Let's take an example over here. We are taking ethyl ethanoate, ethyl acetate is the common name, reacting it with water in presence of H2SO4. We are going to get over here CH3COOH plus C2H5OH. Okay? So this is what we are getting. Or let's take another example. We have CH3C double bond O with a benzene ring. This is phenyl acetate. So phenyl acetate plus water in presence of sulfuric acid. This is going to give us CH3COOH plus phenol. Okay, so this is hydrolysis in acidic medium. That is going to be, when we are taking the hydrolysis in acidic medium, you can see that the reaction that is going to be reversible. But if the same reaction that is carried out in basic medium, the reaction that becomes irreversible. Okay? So acidic medium it is going to be reversible, and basic medium it is going to be irreversible. So let's see what is happening in both the mediums over here. We are doing the reaction in acidic medium. If we are doing the reaction in acidic medium, so we have in the first step protonation that is going to take place. So we are doing the reaction in acidic medium, and we are saying that protonation is going to take place. Protonation का मतलब क्या होगा? This double bond के electrons, they are going to delocalize over here. There is going to be a negative charge. So we are going to get over here RC, OH and OR with a positive charge on carbon. ठीक है? Now this is going to be resonantly stabilized. Okay, so if it is resonantly stabilized, the negative charge that is going to rotate between these two. So we have R, C, OH and OR, the negative charge that is dispersed between both the oxygens which are present. And in case of further, if we are reacting this in basic medium, we are going to get over here the ester back, RC double bond O. So you can see that when we are doing the reaction in acidic medium, we are regaining the ester over here, so it very clearly shows that the reaction that is going to be reversible. Let's now compare it with the reaction in basic medium. In case of basic medium, we have, okay, and this is going to react with OH negative to give us our an addition product which we are going to get over here, negative O negative and OH. Because over here this is negatively charged and you can see that the positive charge that is going to be present at the carbon atom. Therefore, the negatively charged hydroxyl ion that goes and attacks at the carbon atom, and henceforth what we are going to get over here, this hydrogen that shifts, okay, and we are going to get over here RC O negative plus ROH. So this is going to be a irreversible reaction. Okay, so acidic medium mein it is reversible and basic medium mein it is going to be irreversible. So this method that is generally used for the preparation of higher fatty acids where the number of carbon atoms that is going to be more. So the process by which we are going to form the higher alcohols, that process that is known as what? It is known as saponification. So let's understand what saponification means. Saponification is the reaction of alkalis with higher fatty acids. For example, if we are taking over here CH2, COO, C17, H35, CH, COO, C17. This is a triester which we are taking over here. C17, H35. This is a triester, and when we are going to react it with NaOH, this is going to give us glycerol and soap is going to be formed. So we have over here CH2OH, CHOH and CH2OH, okay? And plus with this we are going to get 3 molecules of COONA. So this is the soap which is going to be formed over here, sodium stearate, right? You've taken the stearic acid over here, so the soap which is formed, that is going to be sodium stearate. Then let's go on to the next method of preparation, action of heat on gem dicarboxylic acids. The sixth one, action of heat on gem dicarboxylic acid. What do we understand by gem dicarboxylic acid? When the COOH, two COOH groups, they are going to be attached to the same carbon atom. So they are going to readily lose a carbon dioxide molecule because of their instability. So let's take an example over here. We are taking malonic acid. This is known as malonic acid, and when we are going to heat this, it is going to lose one carbon dioxide molecule, such as to give us acetic acid. ठीक है? So we can prepare acetic acid in this manner. So if we are taking substituted malonic acid of the type RCH, COOH and COOH. This is known as substituted malonic acid. So substituted malonic acid again when heated, that is going to lose a molecule of carbon dioxide to give us RCH2COOH, which is going to be a monocarboxylic acid. So generally when we are heating gem dicarboxylic acid, the result that is going to be monocarboxylic acid with only one carbon atom. ठीक है? Then the next method of preparation is carbonylation of alkene. Carbonylation of alkenes. Carbonylation of alkenes, the reaction that is known as Kaushal reaction. So what are we doing over here? We are taking an alkene and reacting it with carbon monoxide and water in presence of phosphoric acid, H3PO4. The reaction that is going to take place at approximately 350 degrees centigrade under pressure. Okay? So when we are going to get over here carboxylic acid with higher number of carbon atoms than what is present in the alkene. So we have over here CH3, CH2, COOH. This is known as carbonylation of alkenes. Let's take another example over here. CH3, CH double bond CH2. Okay, now please remember that in this case the carbon which is going to have the COOH group, that is going to attack at the carbon atom with lesser number of hydrogens. So what are we going to get over here? Again, we are reacting this with carbon monoxide in H2O in presence of H3PO4. So this is the carbon atom with lesser number of hydrogens. ठीक है, इसके साथ COOH group attach होगा. So the product which we get over here, that is going to be COOH. It is not the carboxylic group will not always attach at the terminal functional group or the terminal carbon atom. This is the terminal carbon atom over here. The COOH group will attack at the carbon atom with lesser number of hydrogens. ठीक है? So इस करके ये जो CH3 है, that is going to come down. So this is what 2-methyl propanoic acid, that is going to be the product in this case. Okay, so इसमें आपको fill in the blanks आ सकता है. What is going to be the product of the following reaction? Okay, so COOH will attack at the carbon atom with lesser number of hydrogens. Then let's go on to the 8th method of preparation. The 8th method of preparation is from acetamides acetamides, anhydrides. ठीक है? Now over here, when we are going to produce acids from all of these, hydrolysis is going to take place. So we are going to do the hydrolysis. For example, if we are taking amides over here, the hydrolysis may take place in presence of an acid or it may take place in presence of a base to give us the respective acid, which is RCOOH plus ammonia. Okay? In a similar manner, if we are taking acyl chloride plus H2O, this is going to give us what? It is going to give us CH3COOH plus HCl. Also you can do this reaction in presence of NaOH, but in that case first we are going to get sodium acetate प्लस HCl. ठीक है, और फिर ये जो सोडियम एसिटेट यहाँ पे बना है इसकी हमको हाइड्रोलिसिस करनी है टू गिव अस CH3, COOH and NaOH. Got it? And any anhydride of the type RC double bond O, O, C double bond O, R, right? और इसकी हम hydrolysis कर रहे हैं in presence of HOH. Let's say that this alkyl group is different. So what are we going to get? We are going to get two molecules of acids. One is RCOOH and RCOOH. Clear? So this is how from acid amides and acid and anhydrides we can form the respective acids. The next is oxidation of long chain hydrocarbons. Ninth method of preparation is oxidation of long chain hydrocarbons, right? Now over here when we are doing the oxidation of long chain hydrocarbons, we are going to use certain catalysts, and these catalysts, they may be manganese acetate, these may be manganese acetate, or we can also use manganese stearate. Right? Manganese acetate or manganese stearate. In this case, if we are taking a long chain hydrocarbon of the type RCH3, the oxidation of this, that is in presence of either of the catalyst, is going to give us the respective acid and a water molecule. The number of carbon atoms which are going to be present in the acid, they are going to be same which are present in the long chain carbon. Okay? So if you are taking neopentane over here, neopentane is going to be what? So this is going to give us what? It is going to give us two molecules of, as there is a branched chain which is present over here, so it is going to give us two molecules of acetic acid, right? And it is going to give us, here you take 4O2, and it will give us one molecule of carbon dioxide plus water. Tertiary carboxylic acid, that is not going to be formed over here. This reaction particularly, that takes place in presence of another catalyst or oxidizing agent which is concentrated HNO3. Okay, so over here this is an exception. Whenever branching is going to take place, in that case we cannot get a branched carboxylic acid. So you're getting over here CH3COOH, and plus you will get carbon dioxide and water. The next, the 10th is oxidation of alkenes and alkynes. Oxidation of alkenes and alkynes. Now over here the oxidizing agents which we are going to use, that is hot alkaline KMnO4, or we can use K2Cr2O7, right? So over here we are taking an alkene of the type R dash, and we are oxidizing it. We are going to get a mixture of acids. The cleavage of the bond that will take place from here, okay? And we are going to get RCOOH plus RCOOH. Okay? In the let's take an example over here. We are taking CH3, CH double bond, CH and CH3. Oxidation, cleavage will take place from here. So we are getting two molecules of acetic acid, 2CH3COOH, right? And if we have a cyclic compound of the type cyclohexene, oxidation, the chain over here that is going to open. So we have a diacid over here, dicarboxylic acid, which we will get. where both these carbon atoms, they are going to be oxidized. Okay? The chain that is going to open, and this is known as what? It is known as adipic acid. Clear? Have you understood? So cyclic compounds में क्या हो रहा है? There is going to be opening of the chain which is taking place, और जो जहाँ पे double bond present है in the alicyclic, wherever double bond is present, there is going to be the cleavage of the bond which is taking place through the double bond. Okay? So these are the methods of preparation of carboxylic acids. Now let's go on to the general physical properties of carboxylic acids. General physical properties of carboxylic acids. It is seen that the lower fatty acids up to 10 carbon atoms, they are going to exist as colorless liquids. Okay? Now over here the higher ones, that is more than 10 carbon atoms, the higher ones, they generally exist as waxy solids. Okay? Then it is seen that the first three members, they have a sharp pungent odor. So when we are talking of C1 to C3, they have sharp pungent odor, whereas from C4 to C9, they have an odor of rancid butter. They have an odor of rancid butter. जो खराब हो जाता है ना butter, उसकी smell आती है. और higher ones, they are going to be odorless. So all those which have more than 9 carbon atoms, they have no smell. Then the next we have, when we are talking of solubility, the lower members, they are going to be soluble in water due to their tendency to form hydrogen bonds with water, right? But as and when the molecular masses, they are going to increase, the non-polar part that will increase and the solubility that increases. So it is seen that solubility decreases with increase in molar mass due to the non-polar part which keeps on increasing, right? So molecular masses, जो boiling points जो हम करते हैं, this is the solubility which we've done. When we're talking of boiling points, it is seen that the boiling points of carboxylic acids, they increase regularly with increase in molar masses. They increase regularly with increase in molar masses. So they have high molecular masses, or they have high, you can say, boiling points because of hydrogen bonding which is going to exist with them, within them. So they generally form, if you're looking at the carboxylic acids, they form hydrogen bond of the type so they generally form diols. So this is the kind of hydrogen bonding which is going to be present, intermolecular hydrogen bonding, which is going to increase the boiling points of acids. Then it is seen that when we are talking of the lower members, as I just told you, that they exist as dimers in vapor phase and in aqueous solution. But when we are talking of carboxylic acid in liquid phase, they are going to exist as polymers. Okay, so we are comparing the boiling points of ethers, alcohols and carboxylic acids. Carboxylic acids, they are going to have the maximum number of boiling point. So in case of ethers, the ethers, they have lower boiling points than alcohols, and alcohols have lower boiling points than carboxylic acid because of the greatest forces of attraction which are going to be present in carboxylic acids. Okay, you've understood till here? Then let's go on to the electronic structure of carboxylic group. Electronic structure of carboxylic group. You know that the carboxylic group that generally has this kind of a structure. Now over here the carbon atom and the two oxygen atoms which are present, that is this carbon atom, these two oxygen present, these are going to be sp2 hybridized, right? Why? Because this carbon is having a double bond with the oxygen, so obviously this is going to be sp2 hybridized. When we are looking at the resonating structure of the carboxylate ion, we see what is the carboxylate ion over here. This is the carboxylate ion. Now we see that there is going to be resonance which is going to occur over here, such that the resonating structure now becomes this. Or in other words, we can say that the negative charge that is dispersed on both the oxygens due to resonance. So both the oxygens also, they are going to be sp2 hybridized. All the bonds of carboxylic acid, they are going to lie in one plane and they are separated by approximately 120 degrees from each other. Okay? Now carbonyl part of the carboxylic acid is electrically neutral. When we are talking of the carbonyl part, that is the carbon over here that has no charge. When we were talking of aldehydes and ketones, if you remember, the carbon that was getting a positive charge and the oxygen was getting a negative charge. In case of carboxylic acid, the carbonyl carbon has no charge on it. It is only the oxygen which is going to have the negative charges which is going to be dispersed. So they generally don't have, you can not say that they have an accurate double bond character over here. They are going to have a reduced double bond character due to resonance. They have a reduced double bond character, okay, due to resonance. So that is the reason why we are going to say that the carboxylic acids, they do not give us the reactions of the carbonyl group. The reactions in this case, when we study, we will see that the reactions, they are quite different from the aldehydes and ketones. Okay? So today we will do only till here. Tomorrow we go on to the chemical properties of carboxylic acids.